Welcome everyone to BTT 151, Fundamentals of Electricity. I'd like to go over your Unit 10 homework solutions. Question 1, sometimes the current will rise and fall at the same rate as the voltage and will reverse the direction of flow when the voltage reverses polarity. In this condition, the current is said to be in phase with the voltage. Question 2, true power or watts can be produced only when both current and voltage are either positive or both negative. Question 3. Inductance is one of the primary types of loads in an alternating current circuit, and it's represented by a capital letter I. Question number 4. An induced voltage is always opposite in polarity to the applied voltage. Question number 5. The amount of induced voltage is proportional to the rate of change of current through that conductor. Question 6. The amount of induced voltage in an inductor can be computed if the resistance of the wire in the coil and the amount of current in that coil are both known. Question 7. How much voltage is necessary to push 0.8 amps of current through 6 ohms of resistance? Well, a standard Ohm's law problem that we should be adjusted to by now using Ohm's law. Current is specified as 0.8 amps, resistance is specified as 6 ohms, solving for the voltage V. V is equal to I times R. We plug the numbers in and we'll get a voltage of 4.8 volts. Question 8. The current limiting property of the inductor is called its inductive reactance, and it's symbolized by the symbol X or X sub L. Question 9. Inductive reactance is proportional to the number of turns of wire in the coil. Question 10. An inductor has an inductance of 0.8 henries and is connected to a 120 volt 60 hertz line. How much current will flow in this circuit if the wire resistance of the inductor is negligible? Well, the inductance specified as 0.8 henries, voltage is 120 volts, frequency is 60 hertz. So remember, the expression for inductive reactance, X sub L, is equal to 2 pi multiplied by the frequency multiplied by the value of the inductance. So if we plug those numbers in, 2 pi is a constant, 3.14 multiplied by 2, or 6.28. Frequency is 60 hertz, value of the inductance is 0.8 henries. Plug those numbers in, we get 301.4 ohms. Now again, we're going to revert back to Ohm's law. We're solving for the current I. In this example, I is going to be equal to V divided by the inductive reactance X sub L. So we plug those numbers in for voltage and inductive reactance, and we get a current of 0.398 amps. Question 11. In a purely inductive circuit, the current lags the voltage by 90 electrical degrees. Question 10. In a purely inductive circuit, no true power or wattage is produced. Question 13. An electrical measurement called the VAR is used to measure that reactive power in a purely inductive circuit. And remember, VAR stands for volt amperes reactive. Question 14. Exactly that definition. VAR is an abbreviation for volt amperes reactive. And then the last question, question 15, volt amperes reactive would be equal to the value of voltage across the inductor multiplied by the value of current through the inductor. So it's going to be equal to I times the voltage. All right, thank you.